This is A-level mathematics. We're going to be doing partial fractions on chapter 15.4. There's a basic format for this type of partial fractions where I have my numerator could be something like this. AX plus B can be split into A plus B. This is over, A is over PX plus Q, and B is over RX plus S. And so now what this does is I need to try and break this up so it could be two different fractions. So I'm going to have this broken up, so I'm going to factor out the denominator, and I'm also going to set this one up here where it's going to be into partial fractions where they're equal to each other. So first thing I'm going to do, I'm going to rewrite this in factored form. So 13x minus 6 over, I could factor out an x. I'm left with 3x minus 2. And I'm going to rewrite that as a over x plus b over 3x minus 2. It's an x right there. Now with this information here, I'm going to go through and separate this. So now I'm going to make this equal to this over here. So given this, I'm going to multiply common denominator. So what's going to happen is I'm going to get rid of some of this. So I'm going to have this going to come out to be 13x minus 6 equals, now this already has an x, so it's going to need this piece over here. So it's going to be a quantity 3x minus 2, and this one over here, it's going to be plus bx. So what I did is I multiplied everything by the quantity of x times 3x minus 2. This piece already had that, so the denominators canceled. This piece didn't have that, so right here it needed this one. Same thing here, cancel out, needed this piece right here. So now I need to try and solve for my a and b to separate my fractions. So let's go ahead and take a look at this at a couple different points. Now I need to cancel out the x. So the easiest thing is if I go right here, if I go x is 0, x is 0. For this one right here, it's going to go away, but this one here, it's not. So it's going to be 3 times 0 is 0, so I have negative 2a. Bring down my equal sign. Okay, this side right here, if x is 0, I have negative 6. So this one's going to give me a is equal to positive 3. Now I'm going to do something similar with the other side. So now for this to be equal to 0, for this one right here, it would be x would equal, so if I move this the other side, positive 2 over 3. So if x equals 2 over 3, this one right here, this one would give me positive 2 minus 2, that's 0 right there. So I would end up with, right here, 13 times 2 over 3 minus 6 equals that 0, so that goes away. This is going to be 2 over 3 b here. Now I'm going to take my calculator and I'm just going to put this in. So let's take a look for this. See if I can move this up a little bit, make it a little bit clearer. So now for this, I'm going to have, so 13 times 2 over 3, close, minus 6. Let's go second right here. So I'm going to have 8/3 over here. 8/3 equals 2/3 b. Multiply both sides by the reciprocal, 3 over 2. So 3 is canceled, 2 is reduced, so 4 equals b. So I have my a and I have my b. So my partial fraction is going to turn into a. So it's going to plug it into this. So it's a is going to be my 3 over x plus, it's the b, 4 over And this one right here is going to be my 3x minus 2. So this is my partial here. I broke up my two fractions. Now let's take a look at this next one right here. So I'm going to use the same thing, but on this one right here, I have 3 terms in my denominator, so that one's going to give me an A, B, and C. So this is going to give me, let's see, I have A over x plus 1 plus B over 2x plus 3, and the last one's going to be plus C over x minus 3. So now if I multiply everything by the common denominator, let's see, over here I'm going to get 12x equals, now A already has this as the denominator, so if I'm multiplying by the common denominator, if it already has that, that means what would still be missing would be this one and this one. So it's going to be A, 2x plus 3, and x minus 3, plus B, so this one's going to need an x plus 1, x minus 3, plus C, and this one's going to need x plus 1, 2x plus 3. Now, this is going to be pretty easy to get rid of a lot of this. So now, let's take a look. So I'm going to do this for right here. So now, if x is equal to 1, if x equals 1, so this one right here, I'm sorry, negative 1. So if x is equal to negative 1 here, so negative 1 would give me a 0, that would make all of that 0. Negative 1 would make this one a 0, so it would make all that one 0. So it would be able to leave me just with my A value. So all of that would go away. So right here, when x equals negative 1, so that's going to go away, that's going to go away, so all I have to do is deal with this one right here. So that's going to be negative 12 equals, so let's see, this is A times, if this is negative 1, so that's negative 2 plus 3, that's 1, negative 1, negative 3, negative 4, so negative 12 equals negative 4A, A equals 3. Alright, so we're going to do the same thing again. So now for this one right here, when x is going to be, so if I move this over, this is a negative 3 over 2, x equals negative 3 over 2. So now every place that I have this is going to go away. So this one right here would become 0, so that goes away. This one right here would become 0, so that one goes away. So right here, I'm going to have, for this one, let's see, it's going to be, let's see, 12 times negative 3 over 2 equals, right here, negative 3 over 2 plus 2 over 2, that's negative 1/2. So right here for this one, negative 3 over 2 minus 6 over 2, it's negative 9 over 2. So I'm putting them together, and I have to have common denominator for this. So 12 divided by 2 is 6 times 3. That's going to give me negative 18 equals, let's see, that's negative and a positive 9 over 4b. Multiply by the reciprocal, 4 over 9. So I'm going to get b is equal to 18 divided by 9, so that's negative 2, times that, it's negative 8. And for my last one here, for c, so when x is equal to, let's say, a positive 3, so that one's going to become 0, and that one's going to become 0, so those go away. So I'm only going to be dealing with this. So if it's going to be here, so 3 times this, so it's going to be 36 equals, let's see, because I got 36 because it was plugging in that 3 there, so that gave me 36 equals that goes this one. So it's going to be C times 3 plus 1 is 4. And right here, this is going to be 3 times 2 is 6, plus 3 is 9. So I'm going to get 36 equals 36C. So C is equal to 1. Now I have my A, B, and C, so now my partial fraction is going to be 3 over x plus 1. And right here, this is going to become a minus, because that B, so that's a minus, 8 over 2x plus 3. And the next one's going to be plus 1 over x minus 3. Alright, this next problem, 15.4.3, we're going to take the integration of 1 over x times quantity x plus 5. Because this is a multiplication down here in the denominator, I cannot do the integration like this right now. I have to separate it into partial fractions before I could do my integration. So what I'm going to do, I'm going to take this, I'm going to go 1 over x minus 5. And that's going to be equal to a over x plus b over x minus 5. Now, let's go through. And so I'm going to get 1 is equal to, let's see, a quantity x minus 5. And this one's going to be plus bx. So when x equals 0 here, x equals 0, let's see, I'm going to get 1 is equal to, it's 0, so that's negative 5a, so a is equal to negative 1 over 5. Now for the next one, when x equals positive 5, that one's going to be 0, and so I'm going to get 1 equals 5b, I'm plugging in the 5 there, because that's 0. So I get b is equal to positive 1/5. So we're going to break apart my integration. So now my integration is going to be from 1 to 4, and I'm going to have negative 1 over 5 over x plus 1 over 5 over x minus 5 dx. So now I could do this integration here because I don't have an issue because there's a multiplication down in the denominator for that. So let's go ahead and do the integration of this. So if I do the integration of this, I'm going to end up having, let's see, this is going to go down, so that's going to be from negative 1 over 5, and that's going to give me ln absolute value of x, okay, plus 1/5 ln absolute value of x minus 5. Okay, so that's going to be that, and it's going to be from 1 to 4. So now I implied the absolute value here because we cannot have, especially when we're dealing with ln, we cannot have any negative values here. And we might end up having that, but, just to make sure that we are not going to. This is always has to be absolute value because anything other than that, I'm going to get domain errors. So let's go through and do this. So right here, let's go ahead and plug in. So it's going to be negative 1/5 ln of 4 plus 1/5 ln of, now 4 minus 5, that's negative 1, so that's why I had the ln of 1 absolute value, right? So right here, that's important because I needed that absolute value for this because it was a negative 1 there. So it becomes a positive 1 minus, now let's do the other one, negative 1/5 ln of 1. So plus 1/5 ln of, now this is going to give me 1 minus, that's -4, -4. There we go, absolute value of -4. There we go. So now it's important that I had that right there, because otherwise it's going to cause me issues later on. Let's take a look. ln1 is going to be 0. So that one's going to be 0. That one's going to be 0. So I have the -1/5 ln4. Now right here, this is going to make this a minus 1/5 ln of 4. So I took the absolute value of that. So that's going to give me -2/5 ln of 4. So I'm going to check this right here. Now ln4, it is a power. I could rewrite it as 2 squared, and then this would become -4, okay, because the exponent always comes out. So it'd be a -4/5 ln2. So let's see, get here. So let's see, we have -2/5 times ln of 4. We have right here -0.5545. Okay, so yeah, that one is going to be correct. So, like I said, another way of rewriting this, which would be rewriting it as, let's see, it would be -2/5 ln of 2 squared. And then the exponent could always go out in front of the ln. So if it's going out front, it's multiplying by that 2/5. So a -4/5 ln of 2 would be the exact same answer. So either answer is acceptable.